our area equation, which we're trying to maximize, I also tell you you have 25 meters of fencing, which means if you add up all the stuff around there, it has to equal 25. What do you call that when you add up the outside of a, it's the perimeter, right? So the perimeter is equal to 25, and that is going to equal what? 2x plus 2y. X plus y plus y. I just add those all up. So 2x plus 2y. All right, there is our second equation. If you have two unknowns, how many equations do you need to solve for the unknowns? 2. If you have 5 equations, you need 5 unknowns, you need 5 equations. If you have 50 unknowns, you need 50 equations. Okay? So we have 2 unknowns, we have 2 equations, we can figure this out. Now, I'm trying to maximize the area. As soon as I say the word maximize, think of it in terms of graphing terms. If you have a maximum, what do you know about the top of that, like that point right there? The derivative is 0, right? So that means I'm going to have to derive one of these. You derive the equation you're trying to maximize or minimize, okay? However, the area equation has 2 variables in it. We haven't done derivatives of multivariables yet. In fact, we don't do them, so. I guess we sort of done implicit, but. So I need to get rid of the x or the y. How am I going to do that? Substitute, all right? You're going to use this equation here to substitute out one of those. It doesn't matter which variable you sub out, okay? In some cases, there's clear advantages to doing one or the other. This one, it doesn't matter, okay? So I'm just going to solve for y using this equation and plug it into there. So if I go 25 minus 2x and divide off the 2, that will be my y value. Does everybody agree with that? Silence means yes. So then this is substituted in for y, because that's what y is. It's 25 minus 2x over 2. So now my area equation is x which I can then just multiply the x in. Which I'm just going to rewrite like this. Now, I have one equation with one variable, right? It's easy to derive that. But before we do, does anybody know what shape that is? Come on. It's grade 11 math. What did you do in grade 11 math? You did parabolas, right? This is a parabola because it's got its power of 2. In fact, this is the graph, okay? 25 minus 2x squared over 2. What we're trying to do, this is an area. Remember, this is area equals this. We're trying to maximize the area. So we're trying to find what is the dimension here that maximizes the area. So we're trying to find this p, i.e. the critical number, okay? So what is my next step here? What, don't look at that. What is my next step here? You're going to derive it, okay? So we have to derive the area function. So I'm just going to call it a primed. The 1/2 is a constant, so I'll pull it out. What's the derivative of 25x? 25 minus 4x. Okay? How do you find a critical number? What makes it 0? So you set it equal to 0. And if you solve for x, you get 6.25. Now you're not done. You have to prove it is a max or a min. Okay, because sometimes you'll get max or multiple numbers. So, prove it's a max. How do you prove if something is a maximum? Number line, first derivative test. And I'm going to show you the second derivative test because it's actually easier in this case. So this is the first derivative test. So that's where you take your 6.25. You test a number on either side of it. It doesn't matter what number. So if I put a number less than 6.25, I get a what? Positive or negative? Less. You get a positive number, which means we're going up. Put a number that's bigger than 6.25, i.e., I don't know, 10. You get a negative number, which means it's going down. If you switch from increasing to decreasing, you have a maximum. Therefore, 6.25 is a max. Now, we talked briefly about something called the second derivative test. Nobody probably remembers it, except for a couple people. And I said it's good for polynomials, or when finding the second derivative is easy. Usually it's complex, but this is pretty easy. What's the second derivative of this? -4 times a half. But key here is that it's negative, right? What does a negative second derivative mean? Concave up or concave down? Concave what? Concave down, right? Concave down? Second derivative concave down, or means negative means it's concave down. So this is, right, concave down. In fact, it means it's concave down everywhere, right? Because it's only -2 in this case. So at the critical number, if it's concave down, you have to be a max because this is the critical number and we're concave down, therefore it is a maximum, right? It doesn't matter. I don't care which test you use, okay? If you like this, use this one every single time, okay? Therefore, it's a max. All right, so we know x is equal to 6.25 gives us a maximum. We got to find the y value. Find the y value and the area. So if we look back up here, we can use this equation. Y is equal to 25 minus 2x over 2. Which if you do that, you're going to get 6.25. Did I specify meters or centimeters? Meters. What shape do we have? And its dimensions would be 6.25 times 6.25, which would give you an area of 39.063 square meters. You could have figured that out from the beginning because it's a square always maximizes the area. If there's no missing sides and things like that, okay? As soon as you add missing sides, then things change. But this is more important for the process, this question. Are there any questions about that? Okay, you're going to generate two equations. One, you'll rearrange it to sub into the other. Then you take that equation, you derive it, set it equal to 0, find your max and your critical numbers, test them, plug it in to figure out what the other dimensions are. Okay? All right, we're going to do ones at the top. So this question right here, this is more like the stuff you're going to see. Okay, so we have, what do we have? A zookeeper wants to add a rectangular outdoor pen to an animal house with a corner notch as shown in the figure. 85 meters of fence is available. What dimensions of the pen will maximize the area? No fence will be used along the walls of the animal house. All right. Again, I'm just going to write everything as X and Y. Okay? So X, Y. What is this length right there? Sorry? X minus 10, exactly. We don't need to use the same amount there. And what would be on the other side? What's this Y side here? Y minus 5. Now it's basically the same question. So it's going to look a little different. We're trying to maximize the area. So what's our area formula? What's the area of the outdoor pen? Just X times Y, right? Because it's the area of the whole thing. But what's the perimeter? Yeah, you just add up all the sides. So it's going to be X plus X minus 10 plus Y minus 5 plus Y. And how much fencing do we have? 85. All that has to equal 85. Okay, what do we do? Collect your like terms. So I'm going to have 2x plus 2y. Negative 10 and negative 5 is negative 15. If I move it to the other side, I get 100. I could simplify this question even further, or equation. Factor out a 2 and divide it off, or just divide the whole thing by 2. There you go. So now we have two equations. We have our area, we have our perimeter. What do I do now? So which variable do you want to get rid of? X or Y? Doesn't matter. You want to get rid of X? All right. So that means I solve for X here. And then that gets substituted right into there. So my new equation is going to be area is equal to 50 minus y times y. Next step, derive it. Then set it equal to 0, find your critical number, which is 25. And then what do we need to do now? Sorry? Test it, yeah. So to show it's a max or a min. So if you're going to do first derivative test, number less positive, number on the other side is negative, therefore it's a max. Or, remember, you only have to do one. If you want to do second derivative, a double primed is -2, which means it's concave down. Therefore, it's max. So what are my dimensions then of this shape? So we proved that y being 25 produces the max. So we can use this to find x. So we know that x will equal 50 minus y. So x again is going to be 25. So this is 25. That's 25. This is 15, right? This is x minus 10, so this will be 15. And this should be 20. And that will maximize the area. Is that okay? All right, your job is the next page. Mr. Cow, farmer, wants to build a fence using the river. So there's no fence along the river. Maximize the... Oh, we're going to use the least amount of fencing. So this time they give you the area. You have to figure out what the fencing is. Do you want help setting it up? So they have a nice picture here, color picture. X, Y, Y. You don't need any fencing along the river. They tell us the area is 125,000 square meters. So that means the area is 125,000 square meters. What's the area formula for this shape? It's going to be the same, x times y, right? And then what dimensions will require the least amount of fencing, i.e. the smallest perimeter to get that area? So what's the perimeter formula? X plus 2y. Now your goal here, here's your second equation. Your goal, this is what you have to derive, because you're trying to minimize the amount of fencing you use, okay? You have to get rid of one of these variables using this equation. So which variable do you want to get rid of? It doesn't matter. So if I use this equation here, and I divide off x, so I get 125,000 over x is equal to y. That goes in for y. going to give you this. And I flip the x up just to make it easier to derive. I multiplied it in. All right, your job is to derive it, prove it, and then I'll put the answer up in a sec.